Okay, this is the third lesson video for Unit 4, Target 5. I'm going to ask for BD. We're going to do the same thing we've done on the previous problems to find BD, which I just highlighted in yellow. And that is, because I have parallel lines, I can split up the other two sides of the triangles into proportional parts. So green over yellow is going to equal blue over pink. So to find BD, I could say 10 over BD is equal to 6 over 2. Okay, cross multiplying is going to give me 20 equals 6 times BD. Dividing both sides by 6 gives me 20 divided by 6 equals BD. 20 divided by 6 is the same thing as 10 divided by 3. So you could say BD equals 10/3 or 3 1/3. I'm going to use 10/3. Then it says find DE. So I'm going to get rid of these highlighted parts. And I want to read the red statement. There's a major difference when finding these two lengths. Why? Then I put in parentheses, this is a 15% of a test type of question. In other words, if you don't know the answer to why it's different to find BD than to find DE, then you're missing a major concept of this unit because you're using two different theorems. So if you miss it, if you don't get this in the next week and a half to 2 weeks, then you're going to take a big hit on your test because it's what we're going to assess you on. Here's the thing. When we found BD, I just got rid of all the highlighted parts. We're using a new theorem. The new theorem is if I have a parallel line inside a triangle, it splits the other two sides of the triangle into proportional parts. So 10 was a part of a bigger segment. The yellow BD, which is now 10/3, was part of a bigger segment. The blue 6 was part of a bigger segment. And the number 2 was part of a bigger segment. That bigger segment being the entire side of the triangle. When I go to look at finding DE, DE is not a part of a segment that was split up by parallel lines. So then I asked my class, what's a different way we would describe DE then? It's not part of a segment split up by parallel lines. Well, DE is simply a side of a triangle. DE is a side of triangle ADE. So if I'm going to use a side of a triangle, if I'm trying to find that, then when I set up a proportion to find DE, I must make sure that every value I'm using is also a side of a triangle. So this is how this target 5 is related to target number 1. Identify similarity statements. Target number 2, use similarity theorems to solve problems. You can include in that finding the scale factor. So DE is the side of a triangle. So if I use DE, which is the bottom of the big triangle, I'm going to write that as a ratio with the bottom of the small triangle. The bottom of the small triangle is 7. I need to set that equal to a part of a triangle. 2 is not part of a triangle. 10/3 is not part of a triangle. What I really need here is I need DE was the bottom of the big triangle. Let's use the right side of the big triangle. That's 8. 6 plus 2 is 8. So DE was the bottom of the big triangle, and 8 was the right-hand side of the big triangle. 7 was the bottom of the small triangle on top. There's an entire small triangle on top. highlighted in green for you. So DE over 7, the bottom of the big triangle over the bottom of the little triangle, is going to equal 8, the right-hand side of the big triangle, over 6, the right-hand side of the little triangle. Cross multiplying tells me that 56 is going to equal 6 times E. So 56 divided by 6 is 9 1/3. Or 28/3. Or 9.3 repeating. So you will have a problem just like number 6, where we test you to see if you know the difference between finding BD, which was simply a part of a bigger side. BD was not a side length of a triangle. It's the side of a trapezoid. So can you tell the difference between finding a part of a bigger side length, BD, or finding the side length of a triangle, like DE? So I know this video is going on 6 minutes. It's probably going to be a little bit longer because I'd like to put the next example with it as well. So number 7 on your paper, you had 4 true-false questions. And it's setting up these proportions to see, are you talking about parts of a segment, or are you talking about sides of a triangle? So AB. AB is right there highlighted in yellow. AB is part of a small triangle. Okay, it's a side length, I should say. It's a side length of a small triangle. But AB is also part of a bigger segment. AB partners with BD to combine to make this big green and yellow segment AD. And I'm using that one right now because that's the fraction they gave me. They gave me AB over BD. So they didn't give me a triangle side length over a triangle side length because the green's not a triangle side. They gave me part of a bigger segment, the bigger segment being from here to here, over the other part. Then they set that equal to part of the bigger segment, AC, over the other part, the small part, CE. So they just used the triangle proportionality theorem. They said part over part equals part over part. Yellow over green equals yellow over green. So this is true. On the second one, they started off with EC. EC is part of a bigger segment. It is not a triangle side length. They put that with AC or CA. So again, we're working with part of this bigger segment that goes all the way down that's intersected by the parallel lines. They want to know if that equals ED and CB. Those blue lines are not the same thing as the green and yellow. The green and yellow are both parts of a bigger segment. BD and CB are both triangle side lengths. That will never make a fraction. I'm not doing that to cross multiply. I'm saying no. So this is false. Not false question mark, false definitely. I'm not going to go through number 3 and 4, but you can go through number 3 and 4 and compare them to what I did for numbers 1 and 2.